Welcome back. In this class, we are going to observe the monochrome encoding representation and also its color representation of NMOS, PMOS, and CMOS in stick diagram and also in layout. Okay. If you observe in the first column, there is a color. That means it is a color, right? Okay. Now in this second column, you are having stick encoding. That means in the form of monochrome. And here in the third column there is a name of the layer, and in the fourth column layout in terms of monochrome. Now we know that the first layer we have considered is N diffusion. Here if you observe that in the stick diagram, okay, I represented the N diffusion with an empty box. Okay, it is your wish, you can able to represent whatever may be the manner. Okay, but you do not have any authority to change the color. What is the color you have to write for N diffusion? Green color. And coming to the layout representation, it is also okay, we do not have any authority to change its representation. We have to represent N diffusion in this manner. Don't forget, very closely represent. Is it clear? Now coming to the next one, which is a polysilicon layer. You can observe this one, polysilicon. The color of the polysilicon is red. Okay, here it is one type of representation, but don't forget I represented in this fashion for stick diagram. Okay, or else you may represent in this fashion for stick diagram. That is entirely your wish, but you can observe the way it is represented in the layout. It is represented from right to left. Is it understood? Now you can observe the third layer, that is metal 1 you are having as a third layer. Is it clear? You can observe the third layer as a metal 1. In this metal 1, if you observe very clearly, we know very well what is the color of metal 1. Blue is the color of metal 1. In stick diagram monochrome, we represented by shading the area present in the box, and whereas in layout it is vertically represented. Are you clear? Now if you observe that in NMOS and PMOS we do not have any metal 2, only metal 1 is there. Is it clear? Now if you observe that contact is represented with a color of black and it is shown in stick diagram like this, whereas in layout we should have a contact cut. This is a contact cut and there is a contact area. Is it understood? And coming to the implant representation, the color of implant is yellow. It is represented in this fashion in stick diagram monochrome, and in the layout monochrome it is represented. If you observe, these two look similar but the size is different. I hope that are you clear. Now you can observe some of the monochrome encoding representation of transistor. You may observe that transistor monochrome encoding representation, and you can observe just now you have seen the polysilicon color and diffusion color. Now you can observe that if it is an enhancement mode transistor, you do not have any implant on this. Just when a poly crosses diffusion, there is a transistor. This L is to W in a sense the length and the width of the transistor. I hope that are you clear. This is symbol in monochrome. Now it is a layout. Don't forget, in layout you have to represent what is the minimum width of diffusion. We know what is the minimum width of poly and diffusion, that is what 2 lambda, and what is the minimum width of poly, that is also 2 lambda. Now let us consider yourself, if it is a depletion mode MOSFET, then for you should have an implant like this. Is it clear? That is a representation here. You may observe very clearly. This is for a depletion mode MOSFET. Are you clear? Is there any variation present in that? There is no variation present in the enhancement mode and depletion mode except this implant. Is it clear, all of you? You can observe this implant, right? In the layout or symbol or stick diagram representation. Is it understood? These are the monochrome encoding representation of NMOS and PMOS. If you look out the CMOS, how it looks like, you may observe very clearly how it looks like. Now you can observe that in CMOS you are having a P diffusion. Why? Because in NMOS we have seen the N diffusion representation. Okay, is it clear? Now you can observe that in PMOS the P diffusion is represented with a color of what? Green. Okay, this is the way I have shown the representation of both N diffusion and P diffusion in stick diagram monochrome. Okay, but in layout you can observe very important point. This is an important point you have to remember. When there is a P diffusion, you can observe N diffusion are closely represented, whereas P diffusion are widely represented. Is it clear? Now my point is, when there is a P diffusion, it should be surrounded by what? PMOS. That is an important point you have to remember. It should be surrounded by PMOS. And first of all, you can observe what is the color of PMOS. Yellow is the color of PMOS. It is not present in stick diagram. Okay, but it is present in what? Layout. In this manner you can able to observe the representation of PMOS in layout. Is it clear? Now coming to some other layers, you can observe some other layers here. Now we have seen metal 1 in the N and P monochrome representation. Now you can observe metal 2 here. Metal 1 is similar to that. You can observe that metal 2 is also represented with a shaded part in the stick diagram. But what is the color of metal 2? Yeah, dark blue or purple. Is it clear? Dark blue or purple. Now how it is going to be represented? Horizontally it is going to be represented, whereas metal 1 is represented as vertically. I hope that are you clear. Now you can observe one more contact. What is that contact? Via. We have seen in the design rules for contacts, via. Okay, via is represented as black color and it is represented in stick diagram in this fashion. But whereas in layout representation, the via contact is going to be represented in this fashion in the contact area. I hope that are you clear. Now you can observe that the demarcation line is present in stick diagram. It is represented with a brown color. Is it clear? Actually the demarcation line is nothing but a P well layer. Is it understood? And it is going to be represented in this fashion in the layout. And coming to the very important one, VDD or VSS contact, that is an important one you have to remember. The color is black itself. Now you can observe that with the help of metal it is going to be represented with a cross mark, either VDD or VSS. But here you can observe that okay, the VDD or VSS is going to be represented with a metal, okay, if with opposite diffusion. That is an important point you have to remember. Opposite diffusion. If VDD generally is going to be give for PMOS, therefore for VDD you should have N diffusion. Okay, then you have a contact cut. Is it clear? Whereas it for VSS, absolutely. Okay, for VSS you should have a contact area and a metal. Okay, then you should have what? P diffusion in this. What is that? P diffusion. Then don't forget, if it is a P diffusion, then you have a contact. First of all, if it is a P diffusion, that should be surrounded by what? Absolutely, that should be surrounded by P mask. Is it clear? That should be surrounded by P mask. That is an important thing you have to remember. Okay, this is for VSS. I hope that are you clear. Okay, now you can observe some transistors here. Yeah, you can observe some transistors here. It is very clear to you. If you observe the transistors, you may observe very clearly that These we have seen in the N also. When poly crosses diffusion or diffusion crosses poly, there is a transistor like this. But you can observe that it is an N-type transistor, therefore N diffusion is used. We are not going to use any P mask. But for a P-type transistor, P diffusion is used. Therefore, we have to use, it should be surrounded by what? P mask. I hope that are you clear. These are some monochrome encoding representation. If you are having any doubts, you may ask. Is it clear, all of you? Thank you very much. Have a nice day.